Welcome back, everybody. We're working with section 3.5 again, where we're still writing equations and graphing lines. That's the goal. Now, in the previous video, we said that our goal was to be able to graph the equation of a line that went through 2 points or that went through a point and it had a given slope. I'm going to call this goal 1B because we're still going to be writing equations of lines. We'll get to the graphs in the next video. It's going to be writing equations of lines, but we're going to do it with slightly different information. This time you're going to write the equation of a line through a given point that is either parallel or perpendicular to another line. Alright, so write the equation of a line through a point that is either parallel or perpendicular to another line. Alright, so what I would like to start with then are the equations of parallel lines. Alright, lots of directions right here. We're going to write the equation of a line through a point P that is parallel, highlighted that, to the line with the given equation. Give you a moment to, or you should pause and write down the directions. Alright, and you see here a point P our line is going to pass through, and it's going to be parallel to the line with this equation. Now I'm going to give myself a little bit more room to write, so I'm going to get rid of the directions here. Alright, there we go. Now, I prefer to organize this problem in a very specific way. First of all, in this problem, there's two different lines that we're working with. I like to call the one that we're writing the equation for L1 and the one that we're given the equation for line L2. And I like to organize the information that's given to us about each of them. So we've got a line L1, a line L2, and they're parallel to one another. Now, we're given that our line L1 goes through the point 4, -1, and we're given the equation of the second line. Now, how is that going to help us out then? Recall that in order to write the equation of a line, you need to know at least one point that it passes through and the slope. And so we know a point that our line passes through. What we need to figure out is the slope. Well, that's why we're given the information about the line that is parallel to. Remember that parallel lines have equal slopes to one another. So what we're going to be able to do here, we're going to be able to conclude that the slope of line L2 is 1/3 because we had its equation written in slope-intercept form and we were able to easily identify its slope. And then since its slope was 1/3 and the two lines are equal or parallel to one another, we know that the slope of the second line is also 1/3. And as soon as you know that, then you can go ahead and use your point slope form in order to write the equation of the line. So we're going to do that now. We know that our line is going to have the equation y plus 1 equals 1/3 times x minus 4. That's using our point slope form. And then really quickly I'll change that over to slope-intercept form. Let's distribute the slope. And then let's go ahead and subtract 1 from both sides. And of course, whenever I subtract 1, realizing there's a mistake there, but I'll fix that. Whenever we subtract 1 from both sides of the equation, we're subtracting 3/3 really. -4/3 minus 1 is -7/3. There we go. Alright, now the mistake that I made here was not really a mathematical mistake, I just miscopied the problem. Instead of saying that our line went through the point -4, 1, I said it went through the point 4, -1. So let's just alter the original problem, and then the work that you see is valid. Let me do that real quick. There we go, so you get the idea of the process. We're going to make another equation of a line as parallel to a line with a given equation right now. There's going to be one more step to this one. Alright, you see a bunch of stuff right there. There's going to be one more step to this one, but it's the same basic process here. Now, we still have a line L1 and L2. I want to organize the information for each right now. Alright, you see the line L1 goes through the point 1/2 -2, and you see the equation of line L2 is x minus 3y is equal to 6. And we know that those two lines are parallel to one another. Alright, well, we have the same information we had previously. We know a point that our line goes through, and we know the equation of the other line. And we're still going to use the slope of the second line to help us find the slope of the first line. But this equation is not written in slope-intercept form, so we don't know the slope of the second line quite yet. The additional step here is that we need to solve this equation for y so that line L2 is in slope-intercept form. Then we can determine its slope in order to write the equation of line L1. All right, so go ahead and solve this equation for y. You can see that so far I've subtracted x from both sides. Now I put it in front of the 6 because I want this to be in slope-intercept form, mx plus b. I want the x's before the constants. I still need to divide by -3, so I'll divide every term by -3, and that will give you this. Y equals positive 1/3 x minus 2. You had a -1 divided by -3, that's where the positive 1/3 came from. 6 divided by -3 is -2. Now with all that, then, we know that the slope of line L2 is 1/3, which means then that we know the slope of line L1 is also 1/3 because they are parallel to one another. Now the rest, try this on your own really quickly. There's your point slope form of the equation. There's the same equation after you distributed the slope. And there's finally the equation of the line after you subtracted 2 from both sides, and it's in slope-intercept form. And again, just as with the previous example, you can see that the slope 1/3 matches up with that slope right there, so the lines are indeed parallel to one another. All right, now what about perpendicular lines? Well, let's take a look at those. Same basic directions here. In this example, I want you to write the equation of the line passing through P that is perpendicular this time to the line with the given equation. Alright, the same basic setup as with the parallel lines problems here in a moment. And just as with that, I'd like to have a little more space, so make sure you've got the directions written down. I'm about to make them disappear from the screen. Done. Alright, well, let's organize this. You know how to do the line L1 and L2 stuff at this point. And of course, a new caveat to this is that now the two lines are perpendicular to one another, line L1 is perpendicular to line L2 instead of being parallel. Now the basic idea is the same. We still need to find the slope of the line that we're trying to write the equation for, and we're going to use the other line to help us find that slope. But of course, the slopes of perpendicular lines are not equal, they're opposite reciprocals of one another. Now you've got all the information you need to do this. Go ahead right now and find the slope for line L2 by writing its equation in slope-intercept form. There's the first step. Here's the second step in that process. And once you've got that slope-intercept form of the line L2, then you can tell that the slope of that line is positive 2/5. Now let's use what you know about the slopes of perpendicular lines to figure out what the slope of the other line is. Line L1 then would have to be the opposite reciprocal of the slope of line L2. That means that its slope is going to be -5/2. So now all that's left to us is to go ahead and write the equation of line L1. And I hope you noticed the special circumstance that I gave you here that makes this super easy to do from this point. Notice that the point that the line goes through is the y-intercept because the x-coordinate is equal to 0, which means that -4 is our b. And if we already know m and we already know b, then we don't even have to bother with the point slope form of the equation. We can just go ahead and write y equals mx plus b, y equals -5/2 x minus 4. One more example for you to try. There it is. Pause the video, see how you do with this. Alright, here we are with the information organized where we've stated that the two lines are perpendicular and so forth. And we're getting ready, of course, to find the slope of the second line. Now, think about what form this equation was written in. That's point slope form, isn't it? And so, isn't this already the slope right there? You didn't have to put this in slope-intercept form to figure it out, it turns out. Hopefully you noticed that. If you put it in slope-intercept form, you still figured out that the slope was -2. Alright, and if that slope is negative 2, that means the slope of line L1 is going to be the opposite reciprocal of that, or 1/2. Now let's go ahead and write the equation for that line. And the only thing that could possibly still be tricky about this is the fact that we've got a fraction and we've got decimals within the same equation. I would change everything either to a fraction or change everything to a decimal. Probably easiest to go ahead and change the fraction to a decimal in this case. But you might also be able to do this mental math, that 1/2 of negative 2.5 is negative 1.25. And so that's what we'll get whenever we distribute the slope, is we'll get y plus 1.5 is equal to 1/2 x minus 1.25. And then subtract the 1.5 from both sides, you've got your equation of the line. Y equals 1/2 x minus 2.75. Alright, so you should be very good at writing equations of lines at this point. Next video is about graphing lines using various forms of linear equations. Thanks, I'll see you then.